All right, so we are doing probability, and I asked you to start with to make me a little tree that said, what's if there's a probability of 1% that a guy walking through the forest would run into a man with cats in a wheelbarrow or a, what'd you say it was? A wagon. Because apparently there's somebody we know that has cats that takes them out for a walk in a wagon. Um, anyway, then what's the probability that he would be wearing a Star Trek costume at the same time? And let's say that that's ST for Star Trek, and this is Catman. And that was a 1% chance, and then this was Star Trek was a 30% chance. And you multiplied them together, did you get, was it 0.003? Oh, but okay, and I asked you to find the one that he would be not Star Trekking, and so that would be a 70% chance, so that would be 0.007. Do you get that that is not 7%? Excuse me, Jerome. That is what? 0.7%. Obviously, it's a very slim chance of that. Mostly because most of our probabilities being hogged by this not seeing Catman, which is sad now that I think about it. A walk where I don't see a guy with cats in a wagon now. It's kind of sad. I'm missing something. Okay. Anyway, that's a tree, and it just shows how you can do all kinds of crazy situations with a tree that you can't do with other simple math formulas. So the trees are really handy for doing these probabilities. Let's talk about cards. That's the main thing you're going to be talking about today is where card problems can get kind of complicated. Do you get that a deck of cards has 52 cards? Do you know that that's divided up into exactly 4 suits? Clubs, spades, hearts, diamonds. Okay? And those suits, if there's going to be exactly 4 sets of them, they must be 4 sets of, you know how many? 13. Good. So 13 sets of 4 cards. Now, if I take a card out of the deck, any one card, I can say there's a 1 in 52 chance of guessing the card that's going to come up. All right? So would you agree there's a 1 in 52 chance of guessing the card that's right here? Okay. So take a guess. What's that? 4 of hearts, she says. And it is the 5 of hearts. Holy cow. She was really close, but still just wrong. Okay. We're not learning how to count cards right now. Okay. So if you go for just any card, you have 52. You don't want to draw a tree for 52 possibilities. But what we do is we talk about what's the probability of getting a heart or a club or a spade or a diamond. And there'd be a 1 in 4 chance, right? Because it's divided in 4 parts. Another way to say a 1 in 4 chance would be that there's a 13 in 52. Because when you reduce that, it's 4, right? There's a 13 in 52 chance of getting clubs, spades, hearts, or diamonds. Then if I take another card out, here's the important part. Do you get that I could either take that 5 of hearts out and leave it out, or I could take that 5 of hearts out and then see what it is and then put it back in the deck? You get there's 2 different ways you can do the trick, so to speak. If I take it out and leave it out, do you get that my probabilities are all changing now? That's what we're doing today. It's called dependent, meaning what I took out will make a difference on what's left, and the probabilities will change. They will depend on what I took out. All right, so if I take out the 5 of hearts, now all of a sudden I don't have 52 cards anymore. What do I have? 51. And I don't have as many hearts. So if I make the next level of my chart, clubs, spades, hearts, diamonds, my clubs, when I went down this road, I took out a club. So there is now less clubs. There's not 13, there's 12 out of 50. Not 2, 51. Do you get that? But the other ones, they're still the same. They're still 13 out of, but not 52, because they took a card. 13 out of 51. And there's 13 out of 51 for this, and there's 13 out of 51 for that. We're going to talk a lot about those. Now, do you get that this is a route right here that had 2 clubs on it? That's the only way I could get 2 clubs, is to follow that path. Because if I follow this path here and then one of these 4 routes, oh, my screen's freaking out. If I did this, I can't possibly get 2 clubs because I already got a spade for my first card. So my 2 clubs route is right there. There's only one of them. And you just multiply this times this to see what's the probability of 2 clubs. But the harder question would be like this. What's the probability that I got at least 1 heart? Because do you get there's a lot of ways you could have that happen? Here's one that had at least 1 heart. This one didn't. This route right here has all 4 of them are going to have at least 1 heart, right? And so there's 4 routes close. You'd have to find out all 4 of these probabilities. You multiply this times this to get this number here, and then you'd have to find all 4 of these plus this one, plus there's one here, clubs, spades, hearts, diamonds. Right there'd be another one, and then there's another one down here. Clubs, spades, hearts, diamonds. There's another one there. So if I wanted to find the probability of getting at least 1 heart, I'd have to take all of these and add them up. Add them all up. You multiply to get them. This times this to get this. And then I take my answers, these answers here, and I add them all up. When I add up those 7 things, no, it won't add up to 100. If I added every single probability together, that would add up to 100. But these 7 things are, what's the chances do you get if I grab a deck of cards? I'm not terribly likely to pull out 2 hearts. Or even just 1 heart is not guaranteed. There's a decent chance, but it's not guaranteed. So to find the probability of getting at least a heart, 1 heart, when I grab 2 cards, or I grab 2 cards, ooh, I got one, yay. What was the probability of that? It was this plus this, and this, and this, and this. And you have to figure out each one. These are big, intense problems. Like last hour, went and increased the size that you have to make the chart a lot, so that you have like a full screen full of your iPad to make the chart on, because these charts are intense. All right, that's the main part, and I guess I want to get 2 things across. One is exactly how do you draw these charts, and the other is what does dependent mean. So I'll give you a situation. You tell me if it's dependent or not. I have these little, I have your gifts. The new little, what do you call them? Little styli. Multiple styluses would be styli. And if there is a pack here, I'm going to hand back. I'm going to put 1 pack at the beginning of each row, and then just have you hand them back. What's the probability that, let's say that there's one of these things that the crazy maker in China decided to insert a $1,000 yuan. What are they in China? What's their currency? Is it yuan? Yuan? If they put that inside the shaft of the stylus, well, you'd need to know how many there were, for instance. Or maybe you could change the question to, oh, I really hope there's a purple one left for me. Okay, well, I do have extras up here, so if there's a color you really like, oh, I really wish I would have got a purple or whatever, then just ask. All right. Okay, so we're back to probability. So for today, what's the main thing? The main thing is about cards. So let's do a simple probability problem. I'm going to see if you can, I'm going to do a little card trick for you. So here's the trick. You have jacks in the deck are considered the bad guys in the deck. And, excuse me, don't interrupt this. The jacks are considered the bad guys in the deck. And when they are all 4 of them together, bad news. They are going to be robbing this bank, which is right here. All right, so it's the biggest bank in downtown LA, And they're going to do it, of course, in a pretty spectacular fashion. So it's almost impossible. If you've seen the card trick before, of course, don't share what's going on. It's almost an impossible mission. So the 4 Jacks take off in their helicopter. They're flying over the cities. And they come in and land on the roof of the bank. Now, there's a lot of good targets in this bank. So the first guy goes down, and he has to take out the security system in the bank first so that they won't see what's going on. The second Jack, he's going to rappel down the side of the building and break in through the window and go after the diamonds. Okay. The next guy, he is going to go down and take out the cash. He's the big burly guy. And the last Jack, Jack of Hearts, is going to stay up on the rooftop, and he's going to guard the helicopter. So there's all kinds of craziness going on in there. The guys are keeping in touch with each other on their little earphones. And the guy that's up on the roof, he's watching out to see if cops are coming, because of course they'll drive up in their cars, and so he'll be able to see them coming. So he looks around, and all of a sudden, from 2 different directions, cops start converging on the place. So he knows they don't have much time. So he tells them, all right, you guys got about 3 seconds to get back up on this roof, because I'm taking off. And so they load into the helicopter. The first guy with the diamonds comes back, and the guy that took out the security system, he comes back. And finally, the guy with the cash, it's really heavy, in the duffel bags, he gets into the helicopter. And so after those just few seconds, all 4 Jacks have made it into the helicopter and fly off into the distance. So who knows what happened? Thank you. Thank you. What do you think happened? So you're saying I should have more than 3 Jacks in this deck, or 4 Jacks in this deck. All right. Feel free to look through it. Here's my 4 Jacks. No. What I'm saying is, you saw me put them into the deck, right? Yeah, this is 1 deck. Just 1 deck. So he was just saying basically there's more than 4 Jacks. If you look through it, there aren't any more Jacks in here. So, any other ideas? Extra cards that weren't Jacks, and you thought those were on top. All right, so your theory was that I had the 4 Jacks, and then I had other cards on the back side of those 4 Jacks. All right, so if you're right, then I could prove it to you, I guess. I suppose I can do the trick one more time here. I'm going to turn this down a little bit. So you're saying what I was putting into the deck wasn't really Jacks. All right. So I'm always up for a challenge. So here is your 4 Jacks flying across the city. 1, 2, 3, 4 Jacks. I'll make sure there's only 4 Jacks here. You believe me? All right. So here's my 4 Jacks flying across the city. And they come in and land on the roof of the building. The first Jack, I'll actually show you it's a Jack. The Jack of Hearts will go down, and he's going to take out the security system. And the Jack of Diamonds, he's going to go after the diamonds appropriately. He's going to be rappelling down the side of the building. The third Jack, Jack of Clubs, he's the big strong guy. He's going to be the one carrying out the cash. Put him in near the bottom. Now the last Jack, in this case, the Jack of Spades. Jack of Spades will be the one up on the roof guarding the helicopter. So now he's going to see, watching for cops coming, so that he can get them out of there in time. Now this is the part that takes very skillful shuffling to make sure that I get those Jacks mixed so that they can get back up to the top in time. Now, if I were to, there we go. I gotta get the guys back up to the roof because I just saw, I guess I'm that jack on the roof. I just saw the cops coming, so I need you back up here in about 3 seconds. 1, 2, 3. 1, 2, 3, 4. All 4 jacks fly off. Yes. Okay, so you think when I was shuffling I was able to move them back up to the top? All right. Very skillful shuffling. All right. Card tricks are always mildly annoying if they work well. So if you feel mildly annoyed, then the trick worked well. No, I don't want to show you how. I will show you a different trick at some point in the future. All right. Well, luckily today we just needed to talk about dependent and independent, and I hope you got the idea that if you take a card out of the deck and you don't put it back in, then you've changed the probabilities. And so what happens next depends on what card you took out. All your probabilities for the next part of the tree will all be different. And to find answers to things like, what's the probability of exactly 2 jacks coming out or whatever, you need to add up all the possibilities on your tree. So a lot of times on one of those problems, you have to add up 7 different probabilities you calculated to get the right answer. Yes, sir. Oh, that would be really cool. That would be. All right. That's all I got for you today. He's already got me.